Hello students, we have already done one example of squaring, like we have taken example of area of a circle pi r square. Now in this video we will take this example of squaring by a kinetic energy, by finding out kinetic energy. This example: find the kinetic energy of a bullet fired from a gun having a mass of 0.05 plus or minus 0.01 kilograms and moving with a velocity of 3.9 plus or minus 3 meters per second. So let's start this. So first we will find kinetic energy using the measured value. This is the measured value. So we are going to find using measured value. First kinetic energy for the measured value. So kinetic energy is given by half mv square, half into mass into velocity square. So this will be equals to half into mass is 0.05. So 0.05 into velocity is 3.9. So 3.9 into 3.9. So let's solve this, and the answer will come to 3.373. So we will take 0.373 as 0.4. So 0.422 significant joules. So this will be the answer. So we have found out this. So this we will name as E0, kinetic energy, E0. So this we got. Now we will be finding for this tolerance, kinetic energy for this tolerance value or this absolute uncertainty. Measured value we found out. This is for measured value. Now we will find out for our absolute uncertainty values, kinetic energy for absolute uncertainty value. So for this we will use this equation. So the equation is like this: delta E by E means our E0, what we have found out, is equals to delta M upon M0. Then half mv square was there, so that's why it will become plus. Here 2 multiplication is there, so it becomes plus. Then that square was there, this square. So this square when it is there, so it becomes as 2. It will come here in front of this and get multiplied with this velocity into delta V upon V0. So let's substitute the values what we know. So delta E we want to find out. So delta E upon E0 just now we found out to be 0.4 joules. So is equals to here 0.4 joules. So equals to then delta M. So let's find out delta M. Delta M is here given as mass is given 0.01. So this is delta M 0.01 kg. So 0.01 kg here. Then we will write here as mass value here as 0.05. This is 0.05. So this value we will write 0.05 upon 0.05 kg. So this kg will go away. Then 2. Then delta V. So delta V into delta V we have to velocity. So velocity is plus or minus 0.3. So delta V is 3. So delta V is 3 upon velocity 0. So this is the real velocity, measured velocity. So this will be 3.9 upon 3.9. So here it is meters per second on the top also, and here meters per second on the denominator. So it will get cancelled. So now we will solve this equation and we will see what is the answer. So now this value will come to this 0.01 divided by 0.05 is going to come as 0.2, and this will come, this whole thing if we solve 2 into 3 upon 3.9, so it will come to 0.4. So now this will come to 0.6. This whole value is coming to 0.6. So 0.6. Now we will further simplify. So delta E upon 0.4 equals to 0.6. So delta E equals to 0.6 into 0.4, which will come to 225 joules. So we will write which is equivalent to 200 joules. So 200 joules. So now delta E, we got this as delta E, value of delta E. So now we will find percentage uncertainty. So we will write this in the format how energy is to be written. So energy, we got kinetic energy as, here our energy was energy as, so we can write here we got kinetic energy value, so 0.4, so 0.400 plus it will come to 200 joules, plus or minus 200 joules. So in this way, yeah, you can write, but we have to write our two significant figures, so we will further rectify it. So and we will here rectify it, so it will become, see 200 joule is there, so we will take 200 joule, delta E as 200 joule. So we can write this as 2 into 100 also, same thing. So delta E equals to 2 into 100. So we can write delta E equals to then 2 into 10 raised to 2. So now we can write kinetic energy as equals to 0.4 means E value plus or minus delta E. So plus or minus delta E. So delta E is 2 into 10 raised to 2. So 2 into 10 raised to 2. So in this way we can write kinetic energy. So in this way you can solve. So the answer is coming to this. So energy. So you can go through this video. In further videos we will take under root and cubing also. So thanks for watching. Let's move on.